problem here that seems pretty obvious. We're going to prove it anyway, that it's written. I think the problem was way back in the 50s. It's a collection of problems, and this is problem 270, which is actually the last problem in the book. Okay, now we're of course going to assume that c is not equal to 0 to make the problem interesting here. All right, now it looks pretty obvious, if you have a 3-digit number in base b, that it wouldn't be equal to c cubed, but I think a proof's required. Now let's take a look here at a common example. Notice the takeaway from this is that all the digits, I'll write them down here, 7, 4, 2 are less than the base. And that's just a common fact of expanded representations. So again, state the obvious, but it does come in handy in the proof below. Okay, so 10 is the base here, and it's the common everyday base that we use. All right, now, but what we can draw, the conclusion we can draw is that these digits c are going to be less than b, right? No doubt about that. Okay. In fact, you can just think of that as a definition of the expanded form. The digits have to be less than the base. All right, now, a natural thing to do right here is just to divide through by c. All right, and this would become b squared. B squared plus b. Let's see, plus 1. And if we divide c cubed by c, we certainly get c squared, right? Now we can see the result follows almost immediately here. We have an equality here, but we also know that c is less than b, but that would mean that c squared is less than b squared, right? We could, if this is true, c squared is certainly less than b squared. But notice that b squared is just the first term here. So if c squared is less than b squared, then c squared is certainly less than. It's almost not necessary to write that, but I will. C squared is less than b squared would imply that c squared is less than b squared. And of course, that's a contradiction. That's impossible. So however you write down contradiction, but this is certainly false, and that means that this statement is true. In other words, we assumed the opposite of what we were trying to prove. We assumed that this decimal digit or decimal number in base b is equal to its expanded form, and when we assumed that it was equal to c cubed, we got this contradiction right here. Okay, so we're done, I guess. I guess we can put a box here if you want. Hopefully that was convincing, and I hope you enjoyed.